In today's class, we are going to look into data augmentation on images using Keras and TensorFlow API. My name is Victor and I'll be your guide in today's tutorial. So let's see what we are going to cover in today's section. We look into the introduction, and by way of definition, we will try to understand what we mean by data augmentation. Why do we augment data and when do we do that? Followed by different types of data augmentation, which we spoke about. We're going to talk about rotation, shifting, and other variations. And because of that, I deem it fit to change this from types to variations. Because when we talk about types, we are talking about data augmentation on single image, maybe multiple images, and even multi-classes. Hence, I'll change this to variations of data augmentation. Now, in these variations, we will see all this in detail. Now, followed by a demo in which we will look at first the official documentation on TensorFlow website and take a demo session on the single image data augmentation. Having said that, let's start by defining data augmentation. Now, augmenting or to augment is an English word which means to increase the size or add to something, say maybe size or quantity of anything. Now, in computer science, especially in data analytics, data augmentation is a strategy used to increase the amount of data by using techniques like cropping, zooming, flipping, sharing, and other techniques. So data augmentation makes the model more robust to slight variation and hence prevents it from overfitting. If you take a closer look at this image, it is an image of an X-ray, specifically the chest X-ray, and you have the darker regions, your soft tissues, the lung section, and then you have the white regions, the brightest being the bone. Here you can say this is the collarbone, and then these are the ribs. What if I tell you that these sets of images, 1, 2, 3, 4, 5, right, that they are the same as the image you have seen above? Would you believe me? Let's look at other variations as well. How about these ones, right? So all these images, we generated them from this single image. By the end of this tutorial, you will be able to replicate the same. That leads us to the types of variations of data augmentation. I have said this briefly, and we will look into it in detail. Now, rotation is a simple term which says I want you to turn this image to a particular angle. Now the angle will be measured not in radians now, but in degrees. So first thing, we start by instantiating our image data generator method. So in this case, let's say we have a variable name called dataGen, right? And I'm going to use IDG for short as image data generator. Now you have what we call rotation angle, rotation underscore range, please, not angle. Now when you see something like this numeric value like 40, what this says is it is 40 degrees. So it means that I want you to turn this to 40 degrees either to the positive direction or to the negative direction. Subtypes of shifting. So shifting, we can do what we call width shifting, and then what else? We can do height shifting. So when we shift widthwise, what does it say? Any idea? Now this widthwise, we shift it either to the what? Left or to the right. To the left or to the right. And it is what? It takes in what? An argument. Okay? That of what? That is of type what? Floats. So here we have our image data generator. Let's illustrate this now. Image data generator takes in argument obviously with underscore shift underscore range. When you see something like 0.2, it says what? It is 20%. So that means it ranges from 0 being the minimum. 0 is same thing as 0.0, no problem, to 1.0, meaning this is the maximum. So we have seen two different values now. First was an integer value it's taken. The next is what? Now your floating value, right? So same thing applies to when we do height shifting. Same thing. Instead of width shift, we just say height. Height underscore shift underscore range. Okay, so we say something like this, maybe 0.2, let's keep it. Again, it says 20%. Okay, either to the left. In this case now, will it shift it to the left or to the right? It will shift it either what? Vertically or horizontally. So height shifting shifts it vertically or horizontally, and width shifting shifts it what? Left to the left or to the right. I'll move into the next thing here, which is crop flipping versus cropping. So when I say flipping versus cropping, what exactly am I actually saying? So when I flip an image, so I'm actually flipping it. Now if I rotate, I'm rotating in a particular direction. How about when I flip the image? Right? So when I flip this image, right, by default it is set to false. That means flipping is not allowed. So flipping again has two subclasses. Flipping. So we can do what we call horizontal flipping versus what? Vertical flipping. So horizontal flip, by default, the argument is what? Zero is false, meaning it is not permissible. But we're going to turn it on now by saying horizontal flip, horizontal underscore flip to be equal to what? True. Alright, same thing applies to vertical flip. Pass it into an image data generator method, and then I will say vertical flip underscore flip is equal to true. Right? One thing that stands out is something we call constant value, that is written as cval. Now, in most cases, you see that the image is padded. There are paddings to the other side of the image. For instance, we saw an X-ray image, right? We saw the X-ray image. Just remember to say the X-ray is somewhere here. Okay, and then if you remember, there are paddings, like some extra pad. You see some extra color here and there. We want to achieve this. Okay, so we want to pad what? Fill the outside, okay, the outside boundaries of this image with what? A constant value. So how do we pass this now as an argument? So this is my image data generator, right? I'll say maybe I have done width shift range, right? So we use 0.2 before, okay? And then I need to change my fill mode. You look into the stuff. Fill mode can be constant, it can be anything. So here I will say constant here. Now I will say now cval. When you see this, say cval as 80. It says what? Take the constant value as 80 and pad this. That leads us to the next slide, which is our demo section. So before I look into the demo section, or before we go into the demo section, it's actually needful to comment on few blogs that helped fuel this tutorial. One is the blog by Jason Brownlee, the Canadian computer scientist. He has a PhD in machine learning, I think so, and his blogs are really awesome. I'm not sure if he has a YouTube channel, but I find his tutorials very helpful. So I'm going to rank these resources now. So this is my first, followed by this on Coursera. Now, funny enough, this is no longer free. It's now around, it costs you around 730 Indian rupees, or approximately maybe 11 US dollars to do this. It's a project, a self-guided project on Coursera on data augmentation. Heavily on, it revolves around Keras. If your college has subscribed, you might as well try completing this to get a proper understanding of what data augmentation is, and even complete the project as well with a verified certificate. But if not, and you feel that you can actually afford the fee, okay, why not do that? It's going to help you a lot. Followed by the third one now, okay, which is the official documentation on TensorFlow. Right, so this is third rank, and these two tutorials, they are quite helpful, so both will be of the same order. Now let's get into our demo section before we conclude this tutorial. Now I will explain something briefly. Let's fire up our Jupyter notebook. Okay, so here we are. You just type Jupyter. All right, so as you can see there, fire this up. Okay, and I'm going to drag this out now, and let's focus on one screen at a time. Now you see here, I'm going to locate my folder on the desktop. It is called Data Augmentation Hands-On. And here I'm going to show you something here, the Lucid version. Here I've actually added most of the resources also in the notebook, because this notebook, the link will be in the description below. You can actually download this and follow along. So first thing we're going to do is I will do this I will do this with you hands-on. So I will restart my kernel to ensure we have a fresh page. Yes. And first thing you see here, we have steps. The first step is to import all the necessary libraries, followed by creating an instance of the image data generator, right? And then after that, we read this image as a single image and check the shape, because the data generator takes a tensor as an input, so we need to reshape this. Okay, and then we put this in a loop, because data generator runs infinite number of times. So to avoid having an infinite number of images generated, which obviously your computer will run out of memory, we need to set a limit to this. And you see something here, use datagen.flow, because we are reading a single image at a particular time. But pay close attention here now, batch 16, right? What does batch 16 mean? Does it mean that we are going to have 16 batches? Yes, you read that properly. So it says that I'm going to generate what? Augment 16 augmented images, right? So 16 augmented images, and those images will be saved in a directory, as you can see here, okay, called what? Augmented. And I'm going to prefix in front of every image, you will see this augment, and then what is the extension is going to be in PNG. Now this you see here is similar to my epochs. If you have worked on CNN, it's a loose analogy to your epochs. Okay, so that says that, see, I'm going to start from 0 and run this 20 times. That means at the end of the day, I'm going to have what? About 21 images generated. Now let's understand this now. So here I am, okay, and I'm going to show you my I'm going to show you the folder, which is the augmented folder. Now you see there are images already here, so I'm going to delete all these images now. Fine. Now, whatever image I have shown you here, okay, you see this cxr.jpg. This image is the same, it's in the same location. As I could have said, let's say if I save it in a location called, in a folder called images, I will first prefix that, right? Images slash, okay? But because the Jupyter notebook is in the same location with the image, as you can see here, all right, see this is cxr. Why don't I all show you this image? It's the same image which I used in the PPT, in the presentation, right? So what I will do now is, the folder where I'm going to save it is empty, is cleared. So that we run this and verify. Now, I want you to, let's look at this, the image data generator, right? So I'm going to type this now, okay? Image data generator. Let's look at it from the official the TensorFlow official documentation, right? Now you see what we need to look at is image data generator. So you scroll down, you see here. So this image data generator class, look at this stuff. It generates batches of tensor image data with real-time data augmentation. Now you understand the reason I said we are going to reshape that into a tensor, right? And these are some of the arguments that you pass into it. Okay, so you see them, right? Here I never spoke about ZCA whitening, I didn't speak about rotation range, I never spoke about brightness, I never spoke about, okay, channel range. So these are all the other arguments also that is what investigating. And by default you see that the rotation range is 0 here. And then let's look at the fill mode. Yes, nearest. Okay, right? So I chose constant. Okay, you can also pass nearest, and C value by default is 0. C horizontal flip by default, false. So you turn it on by saying true. Okay, so this is it. And let's start now our demo. Now you see the first step is to import this, and let's run this. Okay, and this is done. The second step is we create instance of that. So you can see here 45 degrees, we are going to rotate this. Okay, and then you have your shear width and or whatnot, and then this is the constant value now. I mean the fill mode is constant and the constant value is 125. So some random value. So this is done. Let's read this image now, right? Now, and then let's look at the shape. Now you understand now that the image is of size, maybe height 226, width 223, and it is a colored image. Now I need to reshape this into a tensor. That's what this function takes care of that. Now let's look at the shape once again. Now you see this, okay? So what this means now is when you get into the convolution layer, okay, the input sizes is typically the first one, okay, which is the number of images. So what is the number of images here? Because when you say, if you've worked on CNN, you see the first thing is an input, right? So the input gets into a number of hidden layers. You do convolution and max pooling and all whatnot. So it says I need only one image which is of this size. So this is fine now. Now let's run this now, the for loop. So this is done. So I'm going to now check whether it is created or not. So get back here, right? There you are, you got all the images. And if you see, there are about 21 of them, right? There are about 21 of them. So let's see what we did in this class. All right. So we started by looking at the introduction, right? And we looked at the basic definition of what? Data augmentation. Why and when do we do data augmentation? And we followed by the variations of data augmentation, right? Which we saw flipping, cropping, etc. And there are lots of them in the official documentation. And the resources obviously pointing you to the official TensorFlow website, and that of my friend Dr. Brownlee, and then the demo on a single image. So in the next class, we'll be looking into data augmentation on multiple images, and as well as data augmentation on multi-class images, where we have many classes. Say we have classes of cats, dogs, and cars, something like that. Then we might actually want to generate different variations of them. And thank you for making it to the end of this lecture. If you find this video tutorial very helpful, please do us a favor by clicking that subscribe button and just click on that bell icon so that whenever we post new videos, you'll be notified. And feel free to share this also with your friends. And until next time, bye for now.